Hi guys, it's Mrs. Millicent. We're going to do the check your understanding on page 549, okay? It says to refer to the better batteries example on page 546, so let's go back and look at that. I'm not going to read it verbatim, but let's just look at it real quick. Okay, typical batteries last 30 hours, okay? This company says they have a new deluxe AAA battery. After they took a sample of 15 batteries and drained them, they came to the conclusion that the new batteries from the sample last longer than 30 hours. So they did a significance test. They ended up with this p-value, and they did all these conclusions. We'll talk about that later, okay? So what we're going to do is we're going to look at some type 1 and type 2 errors based on these hypotheses, okay? So first of all, it says to describe a type 1 error in this setting, okay? I went ahead and just summarized, wrote down a couple things from the battery example, okay? We had an SRS of 15 batteries. The sample mean time was 33.9 hours. There's our null hypothesis and our alternative hypothesis. The mu that we're looking for is the true population mean lifetime of the new AAA batteries. Recorded the p-value, whatever. Okay, so what's a type 1 error? A type 1 error is when the hoe is true, when the hoe is true, but we reject it. So the hoe would be true, but we would reject it, okay? So what we would think is, we would think the batteries lasted longer than 30 hours, when in fact they only lasted 30 hours, okay? So I wrote that down. Some consequences might be, I spend more money from a consumer standpoint. I'm going to spend more money on these batteries because I think they last longer than 30 hours when they actually don't. So I'm wasting my money. From the company that's producing the battery standpoint, they're going to think their batteries last longer than 30 hours, so they're going to take the money and produce these batteries, advertise them and everything when they really don't. So they're wasting their money and energy too on a battery that isn't better than any other battery. Okay, so we kind of both lose. Okay. For a type 2 error, okay, so now we need to do a type 2 error. A type 2 error, is when, when the ha is true, but we fail to reject the ho. So this is true, but we fail to reject the ho, so we conclude that this is true. So in this case, the new batteries do last longer than 30 hours, but we conclude that they only last 30 hours like all the other batteries, okay? So from a consumer standpoint, I don't buy the batteries. I don't think they're any better. So I'm missing out on a good product, okay? Because I don't think they do any better than any other battery, but they really do. From the company standpoint, they think their new battery is the same as every other battery, so they decide not to make it and market it, and then they lose out on all those profits, okay? So you got to just kind of think through your errors and your consequences. Now the next question says, which type of error is more serious in this case? Well, selling batteries isn't life and death, so this kind of has room for interpretation. Personally, I would think it would be worse from a consumer standpoint if I'm spending money on a battery that I think is better than it really is. So I would think from a consumer standpoint, this might be worse because the new battery really only lasts 30 hours, but I conclude that it lasts longer, so I'm wasting my money. I'm spending money on a product that I think is better than it's not really better, okay? But you can argue either way. This is one of these things is, again, it's battery life. It's nothing consequential to anything major, so it's really open to interpretation or open to your argument on which error you think is worse, type 1 or type 2. So just support your argument and you'll be good. Okay, see you next time. Ooh.